Okay, good morning. Welcome to
MathForKids number 189.
MathForKids number 189. Let's scoot a little forward here so I can scoot back. Scoot forward to scoot back. Okay, we've been talking about some infinite fractions, like 1/3 was 0.3333. And from there we said 1/9 would then be 0.11111, because how do you get there?
Because you just divide by 3.
Just divide by 3. And yesterday we talked about 1/11 was, do you remember what it was?
090909.
0.090909. All right, one more 9 in there. Okay. And that, by the way, means 1/99th is 0.010101. Because why?
Because you just divide by 9.
Just divide by 9. And that made me think we're talking about all these infinitely long lists of numbers. So I thought we'd study, or I'd tell you about a fun little problem, or not really a problem, it's a way of thinking about infinity that this mathematician named David Hilbert came up with in the early 1900s, I think. David Hilbert was a really famous mathematician. Have you ever heard of his name before?
No.
He was regarded as one of the smartest mathematicians in the whole world around 1900. And he came up with a big list of problems that people would try to solve in the 1900s. But one of his explanations of infinity still is used a lot today, and it's called Hilbert's Hotel. And Hilbert's Hotel is an infinitely tall hotel with an infinite number of rooms. I'm not going to write them all down. 10, 11, 12, all the way up to infinity. A lot of people can stay at this hotel. It's pretty tall. But you come up to the hotel one day, and you say, I'd like to check in. And the person at the desk says, oh, we've got bad news. We're full. Every room's occupied. And you say, what? Every room? And they say, oh, yeah. And then you say, oh, wait, but I have an idea. Why don't we just do this? Because I'd really like to stay in this hotel. Really badly. Like to a lot. Why don't you just have the person in room 1 move to room 2? And the person in room 2 can move to room 3. The person in room 3 can move to room 4. The person in room 4 can move to room 5, etc. And everyone's going to move over one room, or to the next room numbered one higher than their room, right?
Yep.
So where does room 20, the person in room 20 moves to?
Room 21.
And the person in room 1000 moves to?
Room 1001.
Okay. Which room is left empty now?
Room 1.
So you say to the hotel, hey, if you just do this, room 1's going to be open. Everyone's going to have a room. Room 1's going to be open. And?
I can stay.
I can stay. Pretty neat, right?
Yeah.
Yeah. Although people are probably going to be pretty mad at you for having to move all their stuff. Right? You ever had an infinite number of people mad at you? Okay. Now what happens if you come with 3 people instead of just 1, and everyone wants their own room? Do you think you could do the same thing?
You can shift everybody over 3.
You could shift everybody over 3. So it's kind of the same idea, right? Where does the person in room 1 move to?
Room 4.
Room 4. How about the person in room 2?
Room 2 moves to room 5.
What about the person in room 3?
Room 3 moves to room 6. No, yeah, room 6.
Okay. Room 3 moves to room 6. Where does room 9 move to?
Room 9 moves to room 12.
Room 12, right. They just shift over 3. They go 1, 2, 3, boom. Where does the person in room 100 move to?
103.
103, very good. And now which rooms are open?
1, 2, and 3.
1, 2, and 3. So the 3 of you can go in. And now you have still an infinite number of people mad at you. But now here's the amazing thing about this hotel. What if you and an infinite number of your friends showed up? Dot, dot, dot. Now we have an interesting little problem. Even if the hotel's full, can we fit an infinite number of people more in? Now you can't shift people over an infinite number, right? Because where would room 1 move to?
Room infinity.
Yeah, that's hard. We don't know where room infinity is. But we know where room 2 is, and we know where room 100 is.
Yeah.
We can't move to room infinity, so we have to come up with a different idea. And the idea here is actually pretty neat. Room 1 moves to room 2. I'll draw this in red. Room 2 moves to room 4. Room 3 moves to room 6. Where does room 4 move to?
Room 8.
Room 8. Room 5 moves to?
Room 10.
10. So what am I doing? What am I telling everyone in room X to do?
Move to room 2x.
So where does the person in room 13 move to?
Room 26.
How about the person in room 201?
402.
402, very good. Now, the rooms that are going to be occupied now are 2, 4, 6, 8, 10, 12, etc. In other words, the rooms that are occupied are all the rooms that have...
Even. No, odd.
The rooms that are occupied
Oh, even.
are even. So the rooms that are occupied are even, and the rooms that are empty are...
Odd.
And now you can have... How many people move in?
Infinite.
You can have an infinite number of people move in. So even if the hotel's full, every room's occupied when you get there. You can say to the person at the desk, hey, let's just do this. And then an infinite number of people can move in.
Well,
Isn't that amazing?
yeah.
But this is like the difference between our numbers. Remember 1/9 was 0.111111, etc. All the digits were there.
Yeah.
And remember 1/99 was 0.01010101. So only the second, fourth, sixth, eighth digit was there.
Yeah.
That's pretty neat.
Yeah.
Isn't that cool? So that's kind of like how what happened here. When you arrived at the hotel, all the things were filled, and then you just moved everyone to the even digits, the even numbered digits, I mean. And then you had room to fill something else in.
Yep.
It's pretty cool, isn't it?
Yeah.
So, did you like Hilbert's Hotel?
Yeah.
Alright. High five. Do you ever want to stay in Hilbert's Hotel?
Maybe.
What room would you want to stay in?
Room 1.
Room 1. Okay. Good job, Mike.